their most recent as well as some historical codes available basically for free. You have the ICC codes, which is the International Code Council, okay? That's the ICC codes, like International Mechanical Code, International Plumbing Code. That's all available through the online links from ICC code. The NFPA code covers our National Electrical Code. That's the primary one from NFPA that you'll use in this course. If you start doing oil and gas, you're going to use NFPA codes because NFPA 31 is your oil, and you have some gas codes and stuff like that under there as well. But NFPA 70 is the NEC. So when you go to the NFPA website, okay, you actually have to log into the NFPA website, and it's free to create an account, okay? The first time you go, you just create an account with any email you want to use, and then you can go into codes and standards, and you can get a list of all the NFPA codes, okay? And you just click on that list of codes. When the page comes back up, okay, you actually have all of your NFPA codes listed on this page. Now, in the case of what I'm going to talk about today, I scrolled all the way down past it because they have to put 70 near the end. Okay, you find NFPA 70, okay, and it's the National Electrical Code. When you click on the National Electrical Code or any one of these codes, okay, you get a choice. You can view the free access, you can buy it or whatever. Now, I use the free access because this thing changes every year and it's expensive. When you get into the free access, you can actually start using the codes right there, okay? It pulls up a little pop-up window. Unfortunately, you can't print them from here unless you screen print. But it pulls up a pop-up window, and you can actually have table of contents where you can just go to different places in the code based on what you're looking for. You can also search, and you have a lot of other functionality in here. Granted, it's not as nice as having the book in front of you. It's not as nice as having the official app, okay? But it's still a nice way to get free access to the codes. You guys don't use the codes. You won't use the codes enough to really want to invest in the $400 or $500 it costs to get all the code books right in front of you. They get updated pretty frequently. We're looking at NEC 2020 today, okay, because it is the current version of the National Electrical Code, but states are still on NFPA 70 2017, 2013. So the states sometimes lag behind. I do have students in this course from Massachusetts. Massachusetts is usually right up to date on the NEC. Okay, you guys are on 2020 at this point. I believe Connecticut is still on 2017. I think they just updated from 2013 recently. And I'm not 100% sure what Pennsylvania is on. I think you guys are on 2017 right now. But I can't swear to that. That's one you'd have to check. Okay, so codes vary. Codes have to be adhered to for new construction and retrofit. Okay, so in other words, if we install a new furnace someplace, if we install a new air handler, if we install a new air conditioning system, we have to adhere to the current codes. Okay? But if we're just fixing a system, if we're servicing a system and going backwards in time, just servicing, repairing, or whatever, you don't have to necessarily adhere to current codes. You have to adhere to the codes of when the system was installed. Any questions on that? Okay, so let's talk about wire sizing. Does anybody want to tell me what the importance of wire sizing is? Why do I care about the size of the wire going from one point to another?
The amount of heat and current they can handle?
Yeah, it all has to do with the amount of heat. Okay? I don't want us to be trying to run a 100 amp service off of I don't want to run a 100 amp air conditioner off of a wire that is only rated for 20 amps. Okay, bad things are going to happen. And it may not necessarily blow the breaker, it might melt the wire down, might melt the conductor down. When you have a breaker panel in a house and you have wire that's sized for a maximum of 20 amps and you have a breaker that's blowing, do you increase the size of the breaker so it doesn't blow anymore? Again, you have a wire size for 20 amps. That's the maximum current. Breaker in there, except for... What was that?
Yeah, you'd replace the wire and then maybe replace the breaker.
Yeah, too many people. And why we actually cover this these days. Okay, too many people believe that the solution to a breaker blowing is to upsize the breaker. Okay, and there are fires that happen over this. So if you have an air conditioner sitting outside, and if the breaker continuously blows, okay, on a hot day or sometimes when it's starting up or whatever, and the breaker is blowing, okay, the solution to the breaker blowing is not to upsize the breaker. Okay, that's what becomes very important with wire sizing. Okay, normally this is the jurisdiction of the electricians. However, there has been such a problem in recent days, all of the states want us to make sure we cover a little bit on wire sizing as a part of HVAC, because there's been a massive problem with this, with houses that never had air conditioning before. We need to now install air conditioning. As people are getting more used to it, they want air conditioning. Okay? So in order to install an HVAC system properly, okay, wire sizing is as important as any other part of the industry. Okay, the electrical circuit and the size is one of the most important things you have to be concerned about. It's important for the service installation, for the technician to understand how electrical power is distributed within a structure. Okay, wire sizing you can't avoid. It's going to play a part into some of the service calls you are on. Okay, most manufacturers usually list in the installation instructions the correct wire and fuse size. However, you may need to calculate wire and fuse size if you're a technician on the job. Okay, sometimes you have exceedingly long runs of wire. Okay, the manufacturers are giving you for the average length that's about 50 to 75 feet of wire. But if you're in a long length of wire, that wire size could change. The National Electrical Code governs the sizes and types of wire that can be used for a specific application. Okay, and it tells us what amperages. So the NEC, even though you're not going to have on your licensing exams, for the most part, you're not going to have NEC questions. We're not electrical. But it still doesn't hurt to realize what's in the NEC. Okay, and again, you have free access to the NEC. Use it. Okay. The correct wire and fuse size is extremely important to the life and efficiency of any equipment. Copper is the most popular conductor in the industry right now. However, back in the 70s especially, aluminum was used because it was cheaper. Okay? Aluminum is still used in the service entrances. Does anybody know what I mean by service entrance? Anybody in here have had electrical before? Service entrance, what is it? Service entrance is the connection from the power line or transformer on the pole or sitting on the ground outside the building, and the connection into the breaker panel. That is 9 out of 10 times not copper. Okay, it's probably aluminum. It's the large wires about the size of inside of a fist, okay, large wires. Copper wire bends easily, has good mechanical strength, resists corrosion, and can be easily joined together. Okay, that's part of why copper wire is so awesome. But aluminum wire was much easier to work with. Okay, now what was the problem with aluminum wire? Anybody could tell me?
Aluminum corrodes a lot easier.
It corrodes. What happened when we joined aluminum and copper together?
It doesn't go well. You got to use a specific paste to join those.
Yeah, aluminum and copper being joined together causes a chemical reaction between the two and will actually corrode out the wires. That goes along with the easy to corrode. It's a correct answer. But aluminum and copper together, you have to use what's called a dielectric paste. Okay, it actually prevents that corrosion that happens in between the two wires. We stopped using aluminum wire inside the walls of houses, okay, in the early 80s, and that was because of the fact that the aluminum wire was causing a ton of problems. If you come across a house, okay, if you come across a house at one point that was wired back in the 70s, it is very possible that some of the wiring in that house is aluminum, okay, and anytime you can have to install something on aluminum wiring, that branch has to be updated. Okay, in other words, if you're installing a furnace or an air handler in a basement or attic and you come across aluminum wiring, okay, an electrician is going to have to update that branch. They cannot just install a new piece of equipment onto a branch with aluminum wiring. And that's most states. I don't know anybody that's now allowing new equipment on aluminum wiring. It's a problem. Aluminum wiring does not have all the good characteristics of copper. Aluminum conducts electricity, but corrodes very easily. The wire connections have a tendency to become loose after they have been corroded. They just fall out of screws, they fall out of terminals, and they fall out of connectors, okay? They will just come loose. Standard wire size in the United States is American Wire Gauge, AWG. You guys need to know that. Okay, AWG is our definition of wire sizing in the United States. Okay, know what this is. Okay, the American Wire Gauge lists the largest wire, which is 000, down to the smallest wire, which is 50. Okay? Now, the numbers, as they go down, the wire gets bigger. Okay, the smaller the number, the larger the wire diameter. It's exactly backwards what you would think. We basically use 16 gauge to 4 gauge wire for line voltages in this industry. What do we use for thermostat wire? I think I've given you this number already once. What do we use for thermostat wire? What's our gauge?
I'm guessing like 24 gauge.
Well, the true thermostat wire is 18 gauge. Okay, it comes with 18 slash and another number, like 6. So if I have 18 slash 6, that tells me my thermostat cable has 6 strands of 18 gauge wire, 6 individual wires that are 18 gauge. Now, we are starting to see the use of 22 and 24 gauge wire. Okay, what is 22 and 24 gauge wire normally used for outside of HVAC? What is it marketed as?
Is that for Cat 5?
Yeah, that's Cat 5.
Cat 6?
Cat 4 and Cat 5. Okay. So we're starting to see the use of that. And the reason we're starting to see the use of that is a lot of builders are starting to build homes and include the wiring for future home automation. Okay, wired home automation devices are extremely popular, even though everything's going to the wireless. The wired are still more, I want to say they're more consistent on their operation. So the wired home control devices, builders are really including the wiring for within the walls. It's a lot easier to pull wiring before the walls are open. Okay, so Cat 5 is being put into just about every room in a lot of new construction. Comes pre-wired. Okay, so a lot of times Cat 5 is now being used. The other thing about Cat 5 cabling, which is the computer cabling, it's shielded. Okay, it has very little outside electrical interference because there's a shield around it. There's a little aluminum shield around it inside the insulation. So
I did notice a lot of Cat 5 used. I worked for a company called Accutech, which is a distribution house for specifically just wire down in Baltimore. And that's what a lot of the contractors, all the orders I was fulfilling, most of them were for Cat 5. But there's so many kinds of wire. It really is like surprising how many types of wire there are. I mean, you fill an entire warehouse with different kinds of wire.
Yeah, but the interesting part about that is, does our thermostats know what type of wire or what color wire I'm connecting between two terminals? Does our thermostat really care?
Yeah.
I know of somebody who went to work for a contractor and actually went into a relatively large residence out in Boston area and decided that the reason they were having problems with their system was because the wire color going between the thermostat and the equipment was not the right color. And yanked out about a couple thousand feet of wiring between the different systems, broke open a couple walls to fix the problem and everything like that. So, and this was an experienced tech. Just because he didn't realize that Cat 5 wire will work the same as 18.7. Okay, it's just you got to get the correct wire colors. If I'm using blue and white striped, I better have blue and white striped on the other side. I can't go to yellow and white striped. Okay, so the wire, we want to pick for what it best handles and what code says we have to handle. Okay, the smaller the wire, okay, the actual longer I can make my runs sometimes, depending on voltages. I don't have as much voltage.
How much wire is kept? Like, do you keep on your truck? You're not keeping those giant, like, because the way most of the time it comes is in those cardboard boxes. What you just pull the wire out of the box. Do you keep those on the truck?
When I was doing a ton of installation work and I was doing a ton of control work, okay, because the contractor I worked for, I was the controls guy. Okay, so I went out to every job and did the control work. When I was doing a ton of that work, I normally kept like 2 boxes of the large boxes of Cat 5 wiring. I kept a couple 500-foot spools of 18.6, 18.12, and I used to keep about 500 foot of various colors of 14 gauge and 12 gauge wire. Okay, nowadays I might have 100 foot of 14 gauge and 12 gauge. And I might have, again, I'm not, my primary job is here at Porter and Chester and YTI, so I don't do as much anymore, but I still carry whatever I have left in a box of Cat 5, because someplace down the road, if I'm out doing one of my side work things, I'm going to come across as someplace where I have to replace wire. I don't anymore carry 18 gauge wire, okay? I don't carry this on my truck anymore. I have no need to. I can replace anything that I need to replace with Cat 5 wire. I don't know if that answers your question.
Yeah, I was just like wondering, just in general, what the amount.
Most technicians have a problem on their trucks. Okay, and you'll understand this one day. Most technicians, I call them hoarders. Okay, most technicians, if I can fit it on my truck, I'm going to carry it because sometime I might need it. Okay, as a service manager, that is the biggest nightmare, okay, is some technicians' trucks are so heavy on material that you can't figure out what they have and what they don't have because they just have everything. And it's crammed into every nook and cranny in that truck. Okay, the reality is, okay, is that you can carry a couple spare motors, some wire, couple spare relays. If you're doing oil, you carry a nozzle collection, some pump strainers, a spare pump, and you don't have to carry as much spare parts. So a couple 100 feet of wire, some Cat 5 cabling, whatever you have left in the box, you're normally fine. You just have to know what to do with it. I know a technician. He's now an instructor here at Porter Chester on one of our campuses. When he was in the field, and it's okay, we joke about it anyways. When he was in the field, his truck got pulled over once at a weigh station because it was too heavy. So yeah, you can carry way too much stuff on a truck. So, but back to this, okay? So, wire gauge 0 to 50, okay? The larger the number, the smaller the wire. I've never seen 50 gauge wire, okay? I can't even imagine. Okay? The type of insulation around the wire determines its application and sometimes the amperage it can be used for. Insulation of different grades is used for different purposes. Some are heat resistance, some are moisture resistance, some are heat and moisture resistance, and some are oil resistance. Okay? Solar resistance is a big issue. UV resistance in parts of the country is a big issue. Okay, for example, where I'm at, I can't install wire any place where sun can get to it without it having UV resistance because the insulation just breaks down and falls apart. Okay? So insulation is a big problem, okay? You have to have the correct insulation for the purpose. Now, when we talk about wire sizing, we have basically 4 factors that we're mainly looking at. We're looking at voltage drop. We're looking at insulation type. We're looking at the enclosure the wire's in, and we're looking at safety. The voltage drop takes into account the distance the wire must be fed. And this is normally calculated by either the technician or the electrician on the job site. Anytime wire calculations go, I just let the electrician do it. Okay, but you do have to realize that there is voltage drop. The longer the wire, okay, the larger the voltage drop is. And believe it or not, it can actually take you under the required voltage of the system if it's not sized properly. Okay? Again, why doesn't everybody put in large wires? Because it's more expensive. Okay, so a lot of times contractors try to put the smallest wire they can possibly get away with. The insulation type, the enclosure, and the safety can be determined by using the National Electrical Code Book. Okay, there are wire sizing tables in the code book that'll give you the allowable amperage for both aluminum and copper conductors. Okay, the code book is the guide for wiring. Okay, you guys cannot avoid following the code book, because if you say to a building inspector, oh yeah, the wire sizing, I decided to use 12 gauge wire even though the code book said I have to use 20 because it should be okay. Or the other way around, I decided to use 20 gauge wire because it was easier to fit, but the code book said I should use 12, but yeah, we should be okay. That building official is like going to shut down the job. Okay, because you cannot avoid following the NEC. Just because you're HVAC and you follow the International Mechanical Code and International Residential Codes, you cannot avoid following the NEC. Okay, voltage drop in a conductor is probably the most important part of sizing wire. Any voltage that drops between the supply, which is your breaker panel, and the equipment, okay, any voltage drop is lost to the equipment. Okay, if the voltage drop is large enough, it's going to affect the operation of the equipment. Okay, sometimes when we're talking the higher end, the high technology equipment, the more efficient, the high efficiencies, the very expensive equipment, a small voltage drop can be detrimental to the equipment. Voltage drop can be easily measured when the equipment is operating by reading the voltage at the supply and subtracting it from the voltage at the equipment. In other words, you go to the breaker panel and you read the voltage going into that branch circuit. Okay, then you go to the equipment. You read the voltage there. You're going to find your voltage drop. If you read 240 volts at the supply and 210 volts at the equipment when it's operating, there's a voltage drop of 30 volts. If the equipment is rated 240, 208, okay, it might work, okay, but it's really pushing it. 30 volts drop is a big voltage drop for a 240 volt piece of equipment. Okay, quite honestly, it's enough to make that equipment, if it has voltage regulation inside of it, it's going to pop out of the circuit. It's going to shut itself down. Okay, now if you get out to a job site and if you have random lockouts, okay, in other words, it doesn't always happen while you're there. It happens along the way someplace. It happens middle of the night, middle of the day. You can never cause it to happen. How are you going to find that voltage drop? What are you going to do? How would you troubleshoot this? Anybody?
Run the system and measure it?
Well, are you always going to be able to get it to run at peak loads while you're there?
No.
You're close, but what is our best way of dealing with this?
Take a few different readings?
Yeah, take multiple
like
readings, but I'll tell you what I would do. I would attach a voltage monitor to it. You can buy them cheap on Amazon. I'd attach a voltage monitor to it, let it record the voltage over a 24-hour period, or even a 7-day period.
Cool. I didn't even know those things existed.
Yeah, they do. Okay, voltage monitors. Okay, they come as test instruments. You can buy them from just about any supply shop, and quite honestly, right now, Amazon has been cheaper than most of the supply shops. Okay, stick a voltage monitor on it. Record it over a 7-day period. Okay, if you can catch the voltage,
you'd have to leave that at the client. You'd have to leave that at the work site, like wherever you're at.
Oh yeah, absolutely. But 9 out of 10 times, if you tell the customer, hey, we suspect there might be a supply voltage problem, let's measure it. I'll have to come back and pick this up in about 7 days or the next time your equipment trips out. I have never had a customer say no. Because they're getting tired of service calls at this point. They're getting tired of the inconvenience. A matter of fact, I normally charge for the voltage monitor being left on site.
Huh.
Hey, you have to buy the test tools. You have the specialized tools. Why not charge for it? I mean, if you spend $400 or if you spend $200 to $400 on test instruments, and you have to leave it on site, you can't use it with another customer while it's on the one site. Don't you think you should be able to charge like $20 a day to leave it there?
Yeah.
I mean, it just makes sense. I mean, charge for your knowledge. Don't give stuff away. Okay, the only time I give stuff away is if I know I'm going to get referrals from that person I give it away to. Okay, real estate agents, I normally, if they have something going on at their own house, as long as it doesn't take any parts, I'll go fix it, because real estate agents give me the best referrals. So you start learning where you can give some services away and where you don't. But use a voltage monitor here, okay? You put the voltage monitor right on the equipment. You don't put it at the breaker panel. You put it at the equipment. Because, again, we need to find out if there's voltage drops along here. Okay? What happens if you have a 240-volt supply coming in from your breaker panel? Okay, it's going through a ceiling here, okay? So I'm just going to put sort of dotted lines here. Okay, I come then into my disconnect. Okay, and then my equipment is over here. Okay, I'll just call it a box because it's something. Okay, we have my equipment over there. Do you know what anybody has done with this portion of the circuit? Can you see it if it's in a wall or in a ceiling someplace? Are you going to be able to see what's there?
No.
No. Well, what if some genius someplace along the way put another 40 amp piece of equipment here? Okay, put a junction box in here. The breaker's still labeled at, let's say the breaker's labeled at 70 amps. Okay, so you have a 70 amp breaker here. This equipment is sized at 50. Okay, and when you're there, this piece of equipment that's sized at 40 is never running, but every night or every couple nights, your rooftop unit trips the breakers. Okay, you have not a clue that there's another piece of equipment in this leg. If you put a voltage and current monitor on right here, okay, you're going to find out that this piece of equipment is not the cause of the problem. There's something else tripping that breaker. And you have proof if you've monitored that voltage. So use the tools that are available. Okay, voltage monitors are awesome. Who here has a high efficiency gas furnace in your basement? I know somebody here does. What, the PVC piping, PVC vent piping that goes outside. Okay, voltage monitors. Okay, those high efficiency pieces of equipment, believe it or not, on the circuit board have voltage monitors. If the voltage drops, the equipment's going to trip out. If the neutral isn't good, the equipment's going to drop out. Okay, so that becomes very important. Again, being able to monitor the voltage. Okay, all of these reasons is once you get into the field, if you start doing advanced troubleshooting, do yourself a favor and get a voltage monitor. Okay, it's worth it. It will save you hours of troubleshooting. Maximum recommended voltage drop for a branch circuit is 3%. Okay, 3%. The allowable voltage drop of most manufacturers is 10% below the nameplate rating. So in other words, if my nameplate rating is 240 volts, a lot of manufacturers will allow me to drop 24 volts under that. Is it a good idea? No. Because if you have a voltage drop of the circuit at 3%, and then my power company is also allowed to drop down 5 to 10%, okay, I could be way outside what the allowable voltage is. So we don't want to have a large voltage drop. Okay, this can really cause you problems as a service tech. So to find the voltage drop, you calculate using Ohm's law. Okay, if a 12-gauge wires run 500 feet, what is the voltage drop when the supply voltage is 240 volts? First, we have to find the resistance of the 12-gauge wire, which is around 1.6 ohms per 1,000 feet. Okay, so if it's 1.6 ohms per 1,000 feet, how much is it per 500 feet?
0.8.
0.8. Okay, you're going to find out when I show you the tables, the resistance is always per 1,000 feet. Okay, so you have to come to your closest divisor by 1,000, okay? We find the amps of 12-gauge wire. 12-gauge wire has a maximum amp of 20 amps. Now we take the formula, 20 times 0.8, okay, and the voltage drop over 500 feet of 12-gauge wire at maximum amperage is 16 volts. Subtract this from the supply voltage of 240, gives me 224 volts supplied to the equipment. Okay, now again, that's at the maximum amperage that the wire's allowed. Take a look at your breaker panel sometime. You will see 20 amp breakers in there. That's on 12-gauge wire. Okay, in most cases, the wiring that's run to HVAC equipment will not exceed 75 to 100 feet. Okay, now, is that direct length or is that length of wire? Okay, what I mean by that, if I go to my breaker panel and if I measure to my outside condenser unit or to the air handler that sits in the attic, okay, I'm going to be way under 75 feet. I think it's like less than 20 to my condensing unit outside if I take a tape measure. And if I go to the air handler in the attic, I think it's about 30 feet. Okay, but is that the length I'm talking about?
Yeah, it's a combined length of everything.
Basically, what I'm talking about is the length of the wire. So the wire goes up into the attic through the wall behind the breaker panel. It then runs to the back of the house, comes out to a disconnect, and runs back to the air conditioner. Okay, so we might have, it's very possible to double your length just because of wire length. Okay, so you gotta be careful about what we talk about wire length. It's not the measured distance between point A and point B. It's actually the length of the wire. Okay, so if I go over here in Chapter 9 of the National Electrical Code, there's two tables. Okay, there's one table that's Table 8. Okay, I know it's probably, let me see if I can increase the size of this at all. See if I can pull this up. This sometimes works and sometimes doesn't. Okay, National Electrical Code, Table 8, okay, is for DC, direct current. Okay, it will actually tell you everything about different gauge wire. So in other words, it tells me, okay, 18 gauge wire has a diameter, okay, of 1.02 millimeters, or if there's more than one wire in there, 1.16 millimeters, or 0.046 inches. I don't care about that. What I care about is what the resistance is with coded wire per 1,000 feet. K feet is per 1,000 feet. So I know that my resistance for a single strand of insulated, okay, 18 gauge wire per 1,000 feet is 8 ohms per 1,000 feet, or 8.08 if you want to get really technical. Okay, if I have more than one wire in the conductor, okay, in other words, if I have a bunch of 18 gauge wire, the resistance goes up a little bit. Why is that?
More wires?
Well, it has more wires, but why does the resistance go up a little bit? We've talked about this a few times.
You got power. You got power going to each leg for each wire, right?
Right, and isn't there a magnetic field that's a little bit generated?
Yes.
Okay, that magnetic field has resistance. Okay, now look at the resistance. If you jump down, and again, I do know this is tough to see, but if we go down to 12 gauge wire, I have 2.01 per 1,000 feet. Okay? So again, we have a significant difference on the resistance. Think back to when we talked about current coil relays. I said that the larger, the extremely large wire on that current coil relay doesn't have voltage drop, okay? It creates magnetism under high amperage. Okay, so again, just be very careful on wire size. Now, why do contractors like running the smaller the wire, the better? Why do they like it?
Easier to run.
It's cheap.
Easier to run. Easier to run
cheaper.
and cheaper, I heard somebody say. That's the reality. Okay, but it can't handle as much voltage. Okay, the other thing to be aware of is, okay, the resistance is at a maximum of a certain temperature. Temperature does affect resistance. Okay, so this table is rated at 167 degrees Fahrenheit. Okay, that's the maximum temperatures these resistances will work at. Okay, now, what do we do in this field with direct current? In most of the field. 90% of the time you're out there, what do we do with direct current? Come on, folks. What do we use direct current for in this field? Correct answer is not much. Okay, so I'm going to go over to table 9. Okay, and I'm going to go over and I'm going to basically say alternating current. Now watch your tables. This first part of table 9 is 3-phase 60 hertz, 3 single conductors. You can find your what, the same thing, different types of wire. Okay, ohms to neutral per 1,000 feet. How much are we losing per 1,000 feet? That table is 3-phase wiring. Okay, I'm going to tell you right now, the majority of voltage drop issues you have is in commercial buildings. Okay, with 3-phase wire. Okay, we also have, let me go back a little bit. Okay, 3-phase.
What is a kVA rating?
Where are you seeing that?
Well, I'm looking at a chart that I have, and it's talking about kVA ratings. I just don't know what that is. I don't know if that's something. Maybe
I think it's based on its voltage, but does on that chart you say what table of the NEC it refers back to?
What they're talking about kilovolts?
Because kVA is kilovolt amps, so it's basically power.
Full load currents, single phase and 3-phase.
Give me the number for 12 gauge wire.
I lost it. Let's see here. I have to find it here.
Okay, and I just have this strange feeling you're going to make me have to ask my electrician buddy again, but I think it has to do with kVA is kilovolt amps. Okay, so V times A is what? Power. Okay, so it's wattage if I'm remembering correctly, but again, I would have to check that.
Yeah,
Sorry,
well,
that's
what I'm looking at the Uglies electrical reference book that we talked about the other day, and it has all of these numbers, all these charts in it for the wiring.
Now, for 12 gauge wire, what does it say?
Size 12. That's temperature. The operating temperatures. Sleep.
While you're looking for that, just so everybody knows, NEC is broken into chapters and articles is the way it's referred to. Okay, the article number, the first number of the article number is the chapter number. Okay, so if we're talking wire sizing, all of wire sizing is handled in Chapter 3. Okay, and Chapter 3 contains articles 310. Okay, and it's basically, that's where we talk about all wire sizing. Okay, so it talks about everything having to do with wire. Okay, now, you will see that every article, for example, 310.4, which is on the bottom of my screen right now, talks about different construction and applications. Okay, NEC is tough to sometimes find because it's tough to find things. So, for example, when we're talking about wire sizing specifically, all the sizing charts and everything, it's all in Article 310. Okay, tells you the maximum operating temperatures, tells you what the insulation, even what trade names are, and it's rated for 600 volts. You go over that, you got to go to another type of wire sizing. And again, you have your resistance, you have thicknesses of insulation here, maximum temperatures, where they can be used in. Okay, so again, everything is in Article 310. Now, 310.15, okay, starts talking about the exact wire sizing. If you don't want to use the table, okay, it talks about amperage tables, okay. Starts talking about the amperages, talks about the length of conductors, okay, and talks about temperature ratings of the different conductors. Temperature matters. There's a different rating that's used between, I mean, you have a different chart at 86 degrees versus 104 degrees. Different ratings. Okay? So just please be aware that this is a trade in itself, how many amperage you can put through here. Okay? Now, probably the chart you're looking at, Dylan, I think you're the one looking for the chart. The chart you're looking at comes pretty close to the one I have up here on the screen right now.
Yeah.
Okay, this one actually breaks it down into pure amperage. Okay? So if I'm looking at copper wire, okay, that's THHN wire, which is the majority of the copper wire we use. Okay, and I'm looking at
THNN?
what?
You said THNN?
THHN.
Okay, yeah, I'm looking at it right now.
Okay, 12 gauge.
It's 30.
30 is the maximum amp, yeah. 14 gauge.
25.
Yeah, that's the table I have up on the screen right now. That's 310.16 in the NEC.
It's in the Uglies reference book, and it has the different types too: copper, aluminum, copper-clad aluminum.
Okay, so wire sizing is important. Don't go over the amperage for the wire sizing. Now let me ask everybody a question. If my voltage drops and my resistance of the wire stays the same, what happens to the amperage?
It goes up.
Okay, so could I be sized properly at one voltage and not be sized properly at another voltage?
Yes.
Yeah, that's why voltage drop, and don't forget the power company can alter voltages. I'm going to tell you, my power in my house ranges between 240 volts roughly at night and jumps to 252 during the day. Okay, that's a pretty significant voltage swing. Okay, at night, again, we're at 240 volts. In the daytime, I'm hitting 252 as an average, sometimes 254. That's a pretty significant swing. Now, I know the reason for that in my case. Okay, it's the solar panels. But the reality is that can really mess up equipment if everything isn't sized properly. So, okay, any questions on wire sizing? I don't want to belabor this point because it's really sort of outside of what normally HVAC technicians are going to do, but anybody have any questions on wire sizing? Okay. Anybody have any questions on anything else in the course that we've covered up to this point? Any questions whatsoever?
Yeah, I have a question about the capacitor.
About the capacitor?
Yeah.
What's the question?
I want to know about like as the residential. I mean, there is what kind of capacitor is used, like as a run capacitor or the start capacitor?
We use both. Run capacitor is always in the circuit. Start capacitor comes out of the circuit based once the motor reaches 75% of its speed.
And
Okay,
what's about the? There are different kind of the motor. So which motor we use in the residential?
All three of them. You could be using shaded pole. You could be using PSC. You could be using CSCR.
So all of those are in the residential?
Yes. The only one we don't really use in residences at all is three-phase.
Okay. And how we know about those motors?
You listen to the lecture I did a few days ago on them, and you read the chapter in the book.
Yeah, I read it.
I've got a question about the test tomorrow.
Sure.
I know you may just tell us to go back and study what we have learned, but is there any sort of study guide you want us to be doing? Any material specifically?
I'm trying to think. I don't do study guides, okay, because basically we've covered everything a number of times. All I can say is there are going to be no surprises on it. If everybody has listened to my lessons and participated in the assignments, you will have no problems. I will tell you there is no schematics on the test, okay, so you won't have to draw any schematics because it is multiple guess. I don't see any problem. Again, I don't see anything that that's even borderline to what we've covered or not covered.
Okay. Cool.
Just review your notes. Review the reading for each of the chapters. There's a chapter summary at the end of the chapter. It's usually on the page right before the end of chapter questions. Review those.
Okay, cool. Thank you.
I think you'll be fine. Again, I'm trying to think through. You know, the math, believe it or not, when it comes to Ohm's Law, that math chapter that I assigned out of the Math for HVAC book is pretty good. I did pull out of the exam, I pulled most of the math questions out, but there are some Ohm's Law questions in there, I think. And again, you're going to have 2 attempts at it, okay? I'm giving everybody 2 attempts at it. So if you don't do well on the first attempt, you've had your review, go back and do it well on the second attempt. Does that answer your question? I'm sorry, I can't be really more specific on that.
Oh, yeah, no worries, it does. It was more for my own benefit so that I know that I really get this material down. Like, I know we've got the 2 attempts, but I like to have it in my brain, ready to act.
Yeah, I think if you review the chapter summaries, you're going to be good.
Cool, I can do that. Thank you.
Anybody else? Okay, guys, I promised I'd try to keep it a little short today. We went a little longer than I wanted to, but that's fine. I hope I answered questions. A couple people are going to send me some screenshots of problems you're having. Let me know when you send me the screenshot if it's affecting your ability to open the assignment. A couple people have emailed me that you can't get into prior assignments. Well, I'm sorry. Assignments of the day, they're closed. Okay? That's why they're assignments of the day. Homework and stuff, unless it's reached the close date, it's still open, but you're going to lose points at this point. I very specifically do not allow people to turn in everything at the end of the course. It's just not right to everybody who participated all the way along. Due dates matter. So with that, that's all I have for today.